When the James Webb Space Telescope took and shared the initial actual image of Oumuamua, the astronomical community bated its collective breath. It was a moment years in coming, years, that is, since 2017, when the enigmatic interstellar visitor was first discovered hurtling through our solar system. After decades of wild speculation, mathematical modeling, artistic renderings, and fragmentary observational data, humankind at last laid eyes on this mysterious object using the most powerful telescope ever sent aloft. The picture was not only an engineering and precision feat, it was a stunning watershed in our effort to comprehend the universe. Released in December 2021, the James Webb Space Telescope, JWST, was first planned to look into the farthest depths of space, yanking off the veil over the early universe and examining the atmospheres of distant exoplanets. It was constructed to observe what no other telescope can: the initial stars, galaxy formation, the radiance of planets around other suns. But amidst all these grandiose plans, JWST also managed to aim its golden mirrors at something much closer and much more strange, a remnant from another star system that had temporarily moved through our solar neighborhood. That remnant was Oumuamua, an object unlike anything astronomers had ever seen. Seen on October 19, 2017, by the Pan-STARRS telescope in Hawaii, it was first believed to be a run-of-the-mill asteroid. But soon it was clear that this was no run-of-the-mill space rock. Its velocity and path unveiled an important fact. It was not held back by the gravitational force of our sun. Oumuamua had come into our solar system on a hyperbolic trajectory and was already exiting. It was the first identified interstellar object to have passed through our solar system, and it generated a frenzy of scientific interest. What made Oumuamua even more interesting was its strange behavior. As it sped away from the sun, it suddenly picked up speed, skidding slightly off its predicted path. Some comets have been known to speed up through outgassing, plumes of vapor that function like natural rockets, but Oumuamua presented no visible evidence of such behavior. No cometary tail. No gas. Simply a quiet, tumbling object that broke convention. Its form, deduced from changes in brightness, appeared to be either cigar-shaped or pancake-shaped. That in itself was without precedent. There was no known body in our solar system that looked even remotely similar. Some theorists suggested that it was a fragment of a broken-up exoplanet. Others proposed exotic explanations: a hydrogen iceberg, a nitrogen shard from a plutonian-type planet, or even, albeit highly unlikely, a bit of extraterrestrial technology. But until now, all this was speculation. The information from its fleeting passage through the solar system in 2017 was sparse and indirect. No telescope had managed to take a detailed picture until JWST intervened. With its unprecedented sensitivity to infrared radiation and high-resolution imaging, JWST was able to detect and image the object, despite Oumuamua being well out beyond the inner solar system. The achievement itself was remarkable. Capturing an image of a rapidly moving object that had by then left the vicinity of the major planets was a feat of immense precision and planning. The outcome was worth every moment of effort. The image didn't only give us visual evidence, it turned speculation into proof. It showed an object elongated but with irregular edges, more jagged and asymmetrical than anticipated. The tidy, sleek space cigar conjured up by early artists was gone. Oumuamua appeared beaten up, with the appearance of a piece of rock that had survived the cosmic equivalent of a harsh ride through uncharted landscape. Its surface was also mystifying. It bore no resemblance to the rocky or icy bodies familiar within our own solar system. There were no signs of craters like on asteroids, nor the smooth, evaporative surfaces of comets. Instead, JWST detected layered formations, strata that suggested geological processes foreign to anything in our celestial neighborhood. Other scientists speculated that these layers might have originated from a larger, differentiated planetary body, perhaps a dwarf planet or moon, before it was hurled out by a cataclysmic collision. The infrared spectroscopic information from the telescope laid another layer of intrigue. It indicated that there were carbon-rich substances present, but not the usual variety found on asteroids. Instead, the spectrum suggested the presence of tholins, complex organic molecules created when cosmic radiation interacts with simpler compounds like methane or ethane. Tholins are known to exist on the surfaces of outer solar system objects like Pluto and Titan. Their presence on Oumuamua strongly suggested that this object had spent eons drifting through the interstellar medium, bombarded by galactic cosmic rays. This piece also suggested a slow process of aging, a type of cosmic weathering, that gave scientists a way to think about how objects could change while they moved from star system to star system. The layers, the tholins, and the misshapen shape all argued for a history of creation, brutality, and survival in the starry vastness. For planetary scientists, that was not mere curiosity. That provided a direct observational confirmation that planetary systems outside our own go through the same kinds of things: accretion, differentiation, collision, and ejection. If Oumuamua was a piece broken off from a larger world, then our solar system is not alone in its turbulent origin and history. Planets collide, moons are smashed, and junk is hurled into interstellar space, maybe routinely. One unexpected finding of the JWST photo was proof of Oumuamua's rotation. Earlier measurements indicated that it tumbled end over end in a wild spin, and the new information confirmed this, indicating it spun on multiple axes. It wasn't spinning evenly, as a top would, but wobbling, similar to a poorly thrown football. It is hard to make something tumble unless there was a violent force that imparted its motion. It lent further credence to the theory that Oumuamua had been blasted into space by a catastrophic event, perhaps the breaking up of a planet or moon. Further hints were provided by how the object reflected light. Its albedo, or reflectivity, differed wildly over its surface. Some areas were dark and dusty, others appeared more reflective, maybe denuded by radiation or previous interactions with stellar winds. This mottled reflectivity suggested a lengthy and complicated history of surface evolution. The possibilities extended far beyond Oumuamua itself. The image transformed what astronomers thought about interstellar garbage. Until then, it had been supposed that such travelers were unusual and elusive. But if our devices were able to detect one, maybe they could detect many. Maybe our galaxy is filled with expelled chunks of planets, traces of extraterrestrial systems that, through some quirk of gravitational destiny, find themselves drifting into ours. The image also confirmed JWST's capacity to observe transient and rapidly moving objects. It demonstrated that, with proper planning, even tiny, faint interstellar travelers could be followed, researched, and deciphered. This paved the way for next-generation missions to not only observe but even intercept similar objects. Already, NASA is crafting ideas such as the Comet Interceptor and examining how to send missions on short notice to study newly discovered interstellar visitors. Beyond science, there was something emotional, almost poetic, about seeing Oumuamua. It was a cosmic message in a bottle, a fragment of another world that had traveled through the void for perhaps hundreds of millions of years, only to be caught in the gaze of human technology. It was a reminder that we are part of a much larger story, that the universe is not static but dynamic and interconnected. The photo kindled renewed public curiosity. The story was picked up by news organizations worldwide. Social media went wild with possibilities, ranging from plausible to far-fetched. Was it a spaceship? Was it the remains of an ancient alien society? While scientists stuck to the facts, the photo permitted a brief moment when science and fantasy danced hand in hand. Schools and museums soon incorporated the JWST photo of Oumuamua into their presentations. It became an icon of discovery and awe. Students were able to observe an actual object from another star system, not a computer model. It sparked a new generation of interest in space, science, and our place in the universe. The larger significance resonated through astrobiology and the search for life. If Oumuamua bore organic molecules created in another system, what else could be drifting out there? Could microorganisms ride on such objects? Could these visitors spread life to planets that they pass by? These questions scientists are now seriously considering. The triumph of imaging Oumuamua also spurred the effort to ready the next interstellar visitor. Telescopes such as the Vera Rubin Observatory, which will go online shortly, will monitor the sky for greater frequency and depth than ever before. These telescopes, supplemented with machine learning algorithms, will most likely find many more Oumuamuas, some even before they reach the solar system. And when they do, astronomers will be prepared. JWST's innovation has demonstrated that not only can we detect these rare cosmic visitors, but that we can thoroughly investigate them as well. Upcoming missions may even point and rendezvous with them, collecting samples or returning even higher resolution information. Slowly fading into the vastness of space, the light of Oumuamua endures, inscribed in the digital frames of the James Webb Space Telescope. It was much more than a rock from another world. Rather, a harbinger of the realities that we are not alone in planet formation processes and share a dynamic and often violent cosmic environment with countless other stars. Ultimately, the true victory wasn't the photograph itself, but what it symbolized, an advance in our capacity to grasp the universe. It was a reminder that science is dynamic, that with each new device, each new look, it transforms. And in that look, we discovered something magnificent, a frozen visitor from a location we might never understand, as seen by the eyes of a people just starting to stretch towards the stars.